from SentinelOne, and he will be discussing using AI for threat hunting. Mike, take it away.
All right. Hello, everyone. My name is Mike Parra. It's a pleasure to be here with you guys today. And we're going to talk about AI and threat hunting and all different things. And but first of all, we're going to talk about AI in general, right? In broad strokes. We're going to try to understand how it works. I guess we all have seen it at work, but just to see a little bit what's behind it, right? That's the first thing. A little bit about me. I'm a solutions engineer for SentinelOne, right? I did computer science. I've been in the industry, in the cybersecurity industry for the last 25 years, and I really enjoy what I do. So anyway, if you have been seeing the recent headlines, it's all about AI. What's going to happen? Am I going to lose my job? Are the machines going to take over the world, et cetera, et cetera, et cetera, right? And the reality is that that's not the case. I think that we're going to be seeing much more AI all over the place, and we're going to learn how to work with it. So are the robots going to replace us, or are we going to work with them? That's the main story. And how is it going to happen? The reality is that we have been using AI for a long time, and it's become so normal for all of us. I mean, we have Siri in our phones, we have Hey Google, we have Alexa, we have, every time we type something, your phone is trying to guess what's the next thing you're gonna type, and so forth and so on. So it's been part of our lives for a long time now. We just become used to it. Now, what about AI? How did it come about, right? So this gentleman right here, John McCarthy, back in the 50s, he's the person who actually coined this term. And he said, what AI is defined as the science and engineering of creating highly intelligent computing devices. That's what it is to get computers to do stuff like we humans do, right? And I'm sure that many of you are in engineering, computer science, or whatever it might be. And let me go back here. I'm gonna date myself a little bit. You probably have seen this in the past. But computers and intelligent computers have been part of our collective imagination for a long time, right? If you remember, has anybody seen this movie? Yes, exactly, right? 2001, A Space Odyssey. And back then, I'm not gonna spoil it for the ones who haven't seen it. It's about these thinking computer, the HAL 9000, right? And this computer has a mind of its own and makes decisions that override the humans that are, piloting this spaceship, right? So that was one, and I was very young, and I was completely besides myself when I saw this movie. They didn't get to see it in the movies, right? It was a VHS. And then we have this, oh my gosh, my clicker is really good. There you go. And then who doesn't remember this one? This is Mother, right? In the movie Alien. And Mother was also fabulous, right? You could get to the computer room right there, and all these screens, all these little flashing lights, and you could type whatever question you wanted. Mother, how's the ship? And Mother would respond, right? What's going on here? What is Special Order 937? Well, sacrifice the crew and make sure that you have the specimen, whatever it might be. And so when I was very young, I got my first computer, right? I was in, I want to say probably starting high school. It was a super powerful 386, fantastic computer, right? And it didn't even have Windows by default. It was a DOS computer. And I remember, just opening up the computer, setting it up, and my parents did a great sacrifice to get me this computer. And I was ready to talk to Mother, or to the HAL 9000, right? And the only thing I saw was this black screen with a little flashing prompt. And I said, what's going on now? Can I just type, how are you doing? Is it gonna reply back to me? Of course not. Of course not. You have to know very specific commands. You have to ask the computer exactly what you want. If you have the wrong command, it just stares back at you and says, I have no idea what you're doing, right? Computers were not intelligent, so to speak. So I'm sure that many of you have if not everyone, has done some scripting or programming or something like that. So how does a regular program work, right? What you could call a deterministic type of program. Well, you type your program, a program has some sort of input, it has an algorithm, and it generates some sort of output, right? That's just how it works. And you have to define exactly what the valid input is. Sometimes you have a little menu. Option 1, do this. Option 2, you do this. Option 3, you do this. What if I type an invalid input? Well, the program doesn't know what to do with it because the algorithm hasn't thought of that, or someone has not programmed that option, and so the output is not available to you. So this is just a normal program. You have an input, you have an algorithm that accepts certain inputs, and then you generate an output, right? Okay, so what's the difference between that and artificial intelligence? Okay, so the first thing that I want to say is artificial intelligence is the overarching overall process, right? The making a machine do intelligent things. And then you have machine learning, which is a subcomponent of artificial intelligence. And then you have deep learning, which we're not going to touch today. So we're just going to talk about this. So the difference between a regular program, right, or a deterministic program, if you may, is that you pretty much define what the input's going to be. You have your little algorithm, and you generate an output, right? In machine learning, it's a little different. You provide the input, and you also tell the learning algorithm what the output should be. And using this machine learning algorithm, this is what you use to learn all possible inputs and which are valid to generate this output. And the product is this model, this intelligent model. So let me give you an example. So let's say I'm talking to Alexa, right? My good friend Alexa, which actually pays attention to what I say. I say, hey Alexa, how's the weather? And Alexa is smart enough to say, you know what, the weather is going to be 83 degrees or 75 degrees, clear skies, blah, blah, blah. And then I can also say, hey, Alexa, is it going to rain today? And Alexa has to understand what is it that I'm asking. Hey, Alexa, should I need a jacket? All of those are possible inputs. Very, very different to select 1, select 2, select 3, right? And all of those things are fed into the machine. Because at the end of the day, the output is, give me the weather. I want to know how the weather is going to be, right? But you throw all possible input to this machine learning algorithm. And so that's what's happening behind. So let me ask you a question. I have some bottles here to give away. So let's get everyone participating here. So why do you think that artificial intelligence or machine learning all of a sudden is everywhere? What is the detonator? What do you think is this reason that we see artificial intelligence everywhere? Because this is not a new idea. This has been around since the 50s. This gentleman that we saw a moment ago, he actually invented Lisp, which is a programming language, a recursive programming language, the father or the mother language of Scheme, which is also a recursive language, which actually helped him program artificial intelligence. But it's 2023. Why do you think it's taken off now? And the answer lays around there. So, any ideas? Anybody? Let's give it a shot. Any idea, right? Why now?
The data for input and output is more widely available.
Ding, 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 ding. That is right. Can I step on this? Am I going to fall? Thank you. That is exactly right. We have tons and tons and tons and tons of data. We can store a whole bunch of things in the cloud. We have stored more data in the cloud in the last 3 years than the entire human history, apparently, right? So that is the reason we have huge samples of data. Now think about it. The more you feed this machine, the better this algorithm gets. So the more, and I don't know if you, I mean, this is not a commercial for Alexa. Just imagine any other assistant, right? I just say Alexa because that's what I have. It. You can use whatever. The more you ask, Alexa sometimes replies, is that the right answer? Is that what you were looking for? Why do you think it's doing that? Because it wants to know if the output I gave you with this model that I created actually satisfies input that you gave me. I think it's right, but if you would confirm if it's right, then I will add it to this process, right? This would validate my algorithm, right? So that is why we have much more compute power and we have much more input. And that is a super relevant idea behind artificial or machine learning. The machine is actually learning. The more things you throw at it, the more samples, the more samples, the more samples help you come up with that model, all right? So the question is, so what, Mike? This is great. So we have an assistant, right? So what's the benefit of this? So in the industry, and all of you want to go to the industry to do whatever it is you're going to do. You might, design planes, design cybersecurity, design, I don't know, whatever it is you're going to do, right? These are the challenges we have right now that we hear from our customers, right? The attacks, it's specific in cybersecurity. The attack surfaces are expanding. An attack surface is whatever is exposed to the outside world in which you can actually touch systems in the inside of your organization, right? So that the surfaces expand. There's no more perimeter. I can have access to a whole bunch of things from this little device that I carry in my pocket all the time, right? So companies, nobody gets, so to speak, married to a single company, right? Everyone has diverse technologies. I have something specific for my firewall, something specific for my mail system, something specific for payroll, to track these other things, students, et cetera, right? How are they gonna all work together? Well, I have so many incidents. There's flashing lights everywhere, right? They're happening really fast. People are working from every place. How do I correlate those things? How do I learn about them at not human pace, but machine pace, right? How can I make sense out of that? I don't have the skills. There's a short of skills. I know you think that everyone in the universe is as smart as you guys are here, but that's not true. That's not true. There's a lack of skills out there. There's so many positions that need to help organizations actually address these problems. And then the last thing is that we have a lot of reactive processes. Oh my gosh, this happened. Let's go fix it. Well, what if we could foresee the problem so it actually doesn't happen? We keep it from actually happening, right? And that's the idea of this technology, right? How can we catch things before they actually happen? And this, again, this has to do with the requirements today, right? I want to compete from every place, any place, at any time. They're not necessarily from 9 to 5, from every place in the world. Bring my own device. Oh, by the way, I want to bring my own device with my own little standards and my little applications, or else, right? So these are real problems. Talking about artificial intelligence and the challenges and the prediction, right? Because that's the whole idea. How can I predict this from before it happens? I work with a client, a really interesting client, and what they do is they do radiology, right? So they do scans of your body, and they look for malicious activity in your body, right? Like cancer, for example. And they're using AI. I actually had this conversation very recently with them, because we were talking about, I knew that I was presenting here, so we're talking about different use. I can tell you my perspective on AI from SentinelOne, and he was giving his perspective from his company. And he says, we're implementing AI, and we're feeding a whole bunch of pictures to the system, right? The before and the after, basically. And the system can predict 3 types of cancer 2 years before they actually develop. Of course, they have to be confirmed by the radiologist, right? Human intervention is always there. But if you can predict an illness 2 years in advance, you can actually do something about it before the problem is here, right? So that's an application of AI, right? Just like we look for applications, we look for indicators of compromise before they happen. Anyway, the ESG, this organization said, hey, in a SOC, in a regular SOC, the Security Operations Center, usually companies have 25 to 49 different despair solutions they work with from 10 plus different vendors, right? So they're not talking to each other. And 57% of these companies say that they're impacted by shortage of skills. Now, I wish I could tell you that I'm a super smart dude. I don't know about that. People might not agree, but I'm not an expert in everything. I know my trade, and that's the trade that I know. And there's many other aspects of technology that I don't know. So some people may be very good at something, but we need skills in other areas, not only the one thing that we can do. And in science and engineering, we may be very good at something, but we need more stuff. So how can AI help us on that? Again, some statistics. Why are these important? Because all of you, I mean, us, we are here already in the as part of the workforce, and you will also join the workforce, right? So yes, there's 62% of organizations that say they're understaffed. It takes about 3 to 6 months to find the right candidate for a job, and there's a shortage of 4 million people with the necessary skills for this. So what are you going to do about it? Let's go to the next slide. And this is where you see, do I build this? Yes. And this is where AI comes in, at least for threat detection. For threat detection, you have all these devices alerting, blinking lights, alerting, logs, all these different things, right? And so you have trillions rows of raw data, whole bunch of data there. From the endpoint, from your email, the Steam, network, firewall, et cetera, right? How can you make sense out of that without so much human intervention? Because we can just go so fast. We get sick, we get tired, we have to go to lunch, we have to go on vacation. AI doesn't, right? AI doesn't have to do any of these things. So how can we go from here to millions of enriched storylines? And the storyline, just to, we're on the same page, is what tells us how did we get here? What is the original process, and what did that process touch, and what did that process spawn, and what is the chain of events that drove us to where we are, right? So from trillions of raw data, we go to millions of enriched storylines, and we go to a handful of actionable things to do, right? How can we reduce this? How can we travel or operate at machine speed? And that is exactly what we get from AI, right? Reduce the alert fatigue, accelerate triage, improve software efficiencies, etc. So what about AI? Well, AI may give us sometimes results that we don't expect, sometimes results that we need to validate, right? Because there's always the variant of how certain these solutions are, right? They're not necessarily predictable all the time. So the question is this: in the past, and I've been in this industry for a little while, so believe me, I was here, right? And back then, this is your typical antivirus, right? There, it has a very specific signature. You have a hash that determines, yeah, this is a bad file, or yeah, it's in my list, or it's not in my list. Let's scan it, et cetera, right? Static files. Today we have this. We have behavior and activity AI. We can check, why is this process doing this? This looks exactly like malicious activity. If I were a bad guy, I would be doing this thing. If you're familiar with the MITRE ATT&CK framework, you can see there's a lot of tactics and techniques that represent malicious activity. So you can say, well, yeah, this might be hidden, but this is exactly this type of activity. This is this tactic, or this is this technique specifically. And when they are happening, we can come to the conclusion that this is malicious activity, not just by the hash of a file, but by the behavior of the process. Now, this is what I want to see. I want you to pay attention to this. Are these fried chicken or labradoodles? Well, if you ask artificial intelligence, they would get it right about 90% of the time. And that's amazing, right? I mean, if you just look at it real quick and then turn your eyes somewhere else, say, I don't know, let me double check. Let's do a double take, right? And you might say 90% is great. 90% is fantastic. Hey, that's very smart. We have made this. We have programmed systems that can catch this with certainty 90% of the time, or 90% certainty. And that's great. However, What if it was this scenario? How comfortable would you be with 90% accuracy? That wouldn't be so good. That would not be so good, right? Okay, so the robot is gonna do surgery on me. How confident I feel with 90%? Well, not so much. One thing is little piece of chicken nuggets and labradoodles. Different story is with medical device and whatnot. So human intervention is always necessary, right? That's been the case for all this time. And so we need to understand that there is a collaboration between humans and artificial intelligence. Now, silicon, which is inside computers, has amazing advantages over humans. That is real. Silicon is really fast. It can pass electricity, conduct electricity really fast. It can stop, it has gates. It can do a lot of calculations really fast, right? And also electromagnetic materials can remember a lot of things. We can store data that will be there for years and years and years, much better than our minds. However, these are tools. These are tools that we're building, that we're making more effective tools. And machine interface is great. They can collect the data, they can search it, they can slice and dice it, do hypothesis testing and everything. But this is where humans come in, right? We have our intuition, we have context, we have ethics, creativity, strategy, et cetera, right? And the merge of both components is what help us work in the real world, right? So yes, we have better tools, absolutely have better tools that will help us do our job faster and better, okay? Let me stop here. Any questions so far? Questions, comments? All right. There might be a question session at the end, but all right. Okay, I'm about to do my second bottle here. So if we're talking about this, let me build and this is probably a recurring theme. In a SOC, in a security operations center, there's several pillars. One pillar can be how you protect your endpoint, right? It's a separate silo of activity. How you protect or how you gather information and intelligence from all the other devices in the network. As we speak, all of this is happening here too, right? There are systems that are logging what students are doing, when they logged in, if someone took a test, if they've paid for tuition, all these different things, right? So that's been collected also here in the SIM. And then the cloud is very prevalent. The cloud is a fantastic tool, right? Gone are the day, for the most part, where people had their little kingdom, right? This is my data center. Nobody can touch my data center. I put guards and locks and bars and everything, and have all my servers in a cold room with a rice floor and all these different things. Still happening, but a lot is moving into the cloud. More and more moving into the cloud. So fantastic. But the problem now is that now we have another silo. I have my silo in the cloud. I have my silo on-prem. I have a security operations center somewhere, and now it's despair. How do you bring all those things together? And you still have the 25% of these threads go untriaged, right? How is that happening? Why? How can we change that? And it will be through artificial intelligence and machine learning. So let's build this slide here. So you collect information from a whole bunch of different sources, right? From threat intelligence, you correlate these events, behavior and analytics, et cetera, and then you need to prioritize that. Who's going to help you with that? How are you going to do that? Well, let me build this out for you. And these are the areas where these different resources shine. So you have, this is where you maximize the value of automation, right here. This is where you maximize the value of artificial intelligence, right? Or machine learning, if you may. And this is the human interaction. This is where we shine right here, when we make that final executive decision, right? I'm going to tell you a little story. There is a difference between automation and AI, right? There's a difference in that. But automation is key. Automation is key. Automation came before AI. So the more we have these things together, the automation part and the artificial intelligence, it will help us find these issues at machine speed. Is that me? Okay, I'm good. Something's gonna react or something. Okay, great. So let's talk about the last few things. So what are the benefits? What are the benefits of using artificial intelligence? The benefits are that it will help us triage, and as you probably know, triage is prioritizing things, right? What is what I need to take care of first? Right, that is triaging, and then we can have an integrated response where it's not just about running a command. You have to make it an I found something, I have to make a change in the firewall, I have to deactivate the account of this user, I have to go and revert these changes, probably have to restore from backup, whatever it might be. It's the orchestration of all of those aspects. And the last thing is staff efficiencies. Yes, we want to have more prepared personnel, but nobody gets to 10 in day one, right? We all start in 1, and then 2, and then 3, and 4, and 5, and we can hone our skills. Well, we can use artificial intelligence to do those things, and I'm going to show you how. So I prepared a video here, but I'm going to skip the video because it's a very small print. Let me tell you how we're using artificial intelligence. So SentinelOne uses artificial intelligence in several ways. In one way is through our storyline. We are looking at the activity in real time of the processes inside computers, right? And we create this linked chain of events that happen. This process started, who started that process? What were the credentials of that user? Where does that process started from? Oh, someone double-clicked a file in the trash bin. Well, that's not very normal, right? And you look at tactics and techniques, and you come to the conclusion that this is a malicious threat. So that's one way, right? Let's stop the threat. Let's kill the storyline. Let's clean after the malicious activity. If it created some persistent artifacts, like maybe it put something in the registry, maybe it created a cron job, or schedule a task, whatever it might be. It create a backdoor, for example. Let's look at everything that touched, and let's eliminate those changes, and let's revert the system back to a pre-attack state. So that's one thing that we do. The other thing what we do, and this is what I'm gonna talk about here, this is what we call purple AI. Why purple? Well, if you haven't guessed by now, purple is the color of SentinelOne, and it's called purple AI. Right? And so what happens here? This is, and you can barely see it, but right there in light gray, right? Right there in light gray, there's a query. While you can find things really easy in our solution, and it's very visual, you can also go out and do some threat hunting yourself. And in order to do threat hunting, you have to type a query. And sometimes these queries can be complex. You have to learn the language, the query language, right? Hey, I want to see this specific artifact on this specific process at this specific location, and et cetera, et cetera. The language is great. If you ask me, I know it a little bit, enough to be dangerous, right? However, what we are doing, we're going back to the HAL 9000, right? Or mother. You can actually type it now. You can actually type the question. You can just type, am I infected by ransomware? By the way, you don't need the question mark. I just added that because it looks good on the slide. But you can type that. You can type that, and purple AI will actually type the query. And if you look close enough, right, it says filter this event type, behavioral indicators, and indicator category equals ransomware, columns, event, time, event ID, yada, 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 yada. If you type that, right, it will give you the same result. But the power of Purple AI is that you can actually type a regular question in English, and it will create the query of what you're trying to find. Number one, it will tell you this. This is actually, you get actually this in the console. It's going to tell you that in plain English. Hey, the most frequent, host that we see is this. Is called the enterprise account, blah blah blah, et cetera, et cetera, et cetera. And if that's not enough, right? If you scroll down on the screen, it'll tell you. And by the way, these are the systems that are impacted by this malware or ransomware, or whatever it might be. So we go back to the skills situation, right? Like, hey, you have to be an expert on this one product to actually make it sing and dance. Well, not anymore. You can actually type a question, and the artificial intelligence will understand what you're saying. And not only that, right? You can ask the same question different ways, right? It's not option 1, option 2, option 3, which would be the equivalent of typing the precise query. You can actually ask the question and say, hey, this is what I'm trying to do. I have another example here, for example. This one says, hey, show me all attacks using LOL bins. And for those that don't know, this is a threat. It's a threat that it actually hides inside the computer and uses just regular commands, right, from your computer for malicious purposes, right? So it's not just a different malware doing its own things. And if you look at the query is all that in light gray. It starts right there in filter, blah, blah, ends right here in event.time. And this is the power of AI. Yes, we use AI to do the detection and see the timeline and the storyline and all these different things, but we have brought it up another level up there, right? It says, hey, just tell me what you're looking for. Tell me what you want to know. I will type the query for you. And once I type the query for you, I'll show you the results right here in plain English. Hey, the most frequent unique value is endpoint name, it's blah, blah, blah. I see this with 675 instances and whatnot. So it's gonna tell you what it found. It's gonna tell you the machines where it found that problem, right? And after that, it's gonna say, and oh, by the way, all of those are, I'm sorry, you can scroll down in the real application, right? Here I have to have it in different slides. And then down here it says, hey, by the way, let me recommend you a couple more questions. These are the other questions that you can ask me that I have come to the conclusion that might be of interest to you, right? What about if you ask me, what are other lol bins that have been observed in this column, for example? What about this thing? What about that? And oh, by the way, so I'm suggesting some other questions, and these are the suggested actions. It doesn't mean that you need to do all these things, but just from my experience dealing with this problem, you should probably disconnect from the network, these endpoints, right? Or maybe fetch these files, right? Et cetera, et cetera. So at the end of the day, you will decide what to do. But AI has the power to say, I'm going to answer your very simple question. I'm going to give you all these details. I'm going to suggest other questions you can ask me if you want to see that information. And I'm going to suggest some actions on how to remediate or how to counterattack this problem. And that is the power of AI. That's how you can go beyond, let's look at a whole bunch of logs, let's do some basic correlation, and let's hope for the best. Right? This is the last example I have. Like, for example, it would be okay if the admins in a network are doing a scan, right, in the network. They're trying to figure out if there's any ports open, if someone is deciding to host a web server on their laptop, if there's an attack going on, et cetera, et cetera. But nobody else should be doing this, right? I should not be able to go to my computer and start port scanning everything. So you can ask a question, hey, show me the endpoints running unauthorized network scans. Just like that. Can you find that information on your own? Yeah, you can type that query in light gray, right? That's the same query. You can ask the same question in different ways, right? You get a summary. You get a summary of the findings, and then you get the actual systems that are actually using these scans, or that are actually scanning the network, right? So, just like the previous example, it says, hey, by the way, these are other questions you can ask me that go in the same vein as what we have been discussing, and these are the actions that I recommend you can do. And that is the power of AI. Let me ask you a question. Why would you think this can be powerful, or is powerful? Anybody? How can this help you? Yes, please. It makes it easier to? Absolutely, absolutely. And yes, there you go. Have another bottle coming, a bottle coming your way. That's right. That's right. Everyone says we use technology to free our resources so we can do more important things. I've been hearing that for a long time. I've been in the industry, like I said, for a long time, right? And we always hear that, hey, we're helping you with automation so you can do this, you can have more free time to do more important things. Or now it's AI. We have AI, so your resources can do more important things. And you know what? Maybe more important things are, hey, I can be home without having to extinguish a fire on Sunday morning, for example, right? That's probably the more important thing that I can do. I can actually train new resources in my organization. I can actually let people bring their own devices. I can actually have them work remotely. I can actually not see the name of my organization in the newspaper because it was hacked, right? All of those things, right, is what we're looking for. You sleep better at night, not be in constant panic of what's going on, what's happening in my network. Can I find this information? Well, I need a PhD on how to find these things, right? If I can ask simple question, what systems are doing port scans in my organization? Are there any other victims of ransomware? Do I think, can you tell me any backdoors that might be installed, et cetera, et cetera. Anyway, that is the conclusion that yes, we should not be afraid of artificial intelligence. We can do things together. And finally, this is my last slide. Yes, chicken or labradoodles, 90% effectiveness. But if we work with humans and artificial intelligence, we can be 100% correct, right? Is that ice cream or are those Dalmatians? Anyway, that's what I have for you. Thank you so much for your time. Really, really appreciate it.